Good afternoon. My name is Jeff Gherardi. Welcome to the EXALEAD OnePart Deep Dive demo. We're going to be talking about the EXALEAD OnePart search engine. It's a new product for us from Dassault Systems, and it's a tool that's going to bring a Google-like experience to searching multiple data sets across different sources, multiple file shares, multiple PDM vaults, PLM systems, things like that. So a single search box experience for the user. So we'll take a look at how it looks through the client, through the browser, and we'll start out by first giving you a brief overview of what the tool can do for us. So we've been previewing this to a couple of our customers so far, and really the use cases that our customers are turning around and presenting us with, number one is part reuse and part number consolidation. So identifying files in our system or across multiple data sets that may be utilizing the same part number, or they may be the same 3D models, assigning multiple part numbers to those. So being able to consolidate those numbers for procurement, for purchasing, for testing and validation, basically streamlining those processes by consolidating the number of part numbers that we have. Another use case that we have for this is actually pre-data migration project cleanup. So a lot of our customers are engaged in mergers and acquisitions and acquiring different companies, business groups, where we may have different data sources, network shares, PDM vaults, things like that. And there may be a significant project to actually combine that data into a single source, get it into your PLM system or PDM system. And this is data that EXALEAD OnePart can index very quickly, make searchable very quickly, while we're still planning out that data merge or data migration activity. So you can start utilizing and searching and revealing that data almost immediately. We talked a little bit about deduplicating data. This is especially prevalent if you've got multiple PDM systems where you've made a copy of one and put it in another location, for example, because it was, too poor of performance to have everyone using just one environment. We saw that commonly with the workgroup PDM system. Also, folks that are transitioning between CAD systems where you have similarly shaped files, or you've taken a file from one system and you've remodeled it in a new system going forward. So being able to identify those files that have the similar 3D shapes and search on that. And then a fourth use case that's been presented to us is really in alternative part searches. So we've got a customer that's going through a RoHS initiative right now where they've got parts that are compliant and non-compliant, and they're spending a lot of time trying to find acceptable alternatives for their non-compliant parts. So being able to find alternates that are the same shape, same size, that can be swapped out in the designs without significant design impact or effort to move holes, remanufacture things to make new components fit. If you can search on the shape of your objects and find similar alternatives, these are things that EXALEAD OnePart is going to enable for us that we really don't have a great tool set to do right now. So the information challenge that we're faced with in engineering is finding and reusing legacy assets. That's something that unless you have a lot of tribal knowledge, a lot of experience at your particular company, it may be difficult to know where that legacy data is for reuse. Being able to identify the appropriate files for reuse. Really, the information challenge that we're addressing with EXALEAD OnePart is making it easy to find legacy data not only by file name or metadata attributes. Our PDM systems, our PLM systems do a pretty good job at that right now, but finding them across multiple data sources and finding similarly shaped, the 3D similarity results. So finding similarly shaped components as appropriate alternatives for part reuse. So let's talk a little bit about the OnePart decision. Okay, as engineers, as designers, we're tasked with, we need a part. And the question that we should be asking ourselves, that maybe we don't ask all the time, but the question that we should be asking is, do I need to design it? Okay, and the answer, is pretty straightforward. Yes, I need to design a new part. Or no, I can reuse an existing part. So let's talk about designing a new part first. Okay, it's easy to do as a skilled engineer. It may take me 30 minutes, a couple hours to create a new part number, right? A new design here. But there's a lot of downstream implications there. That part then has to be tested. It has to be released. It has to go into production. Then there's supply chain management. There's quality inspections. There's warehousing and inventory and things like that. If I don't need to design my part, okay, if I have a way of finding the part that I need very quickly, very easily, then I can immediately use that part, and I don't have to go through the testing, the validation, the supply chain issues that all add time, it adds cost, it adds additional people touching the process, and we can actually quantify those costs. As an engineer, I may say, yeah, it takes me 30 minutes, let me just whip that up. But we also have to consider all these other folks involved in the process for releasing a new part or generating a new part number. And some studies from the Aberdeen group have shown that those costs can work their way up to $23,000 or more, depending on your process for introducing new part numbers. So the cost to your companies is large, not only in design and manufacturing costs, but in the non-manufacturing costs. Right, the administration, the supply chain, the inventory management, so things that we'd consider the non-engineering or non-manufacturing costs. We're spending less time innovating, we're spending less dollars in R&D if we're spending a lot of our time and resources redesigning components that have been built or designed or manufactured by us at some point in the past, or at least similar to those components sometime in the past. And ultimately what happens is we've got duplicate parts that start propagating through our inventory. So we're maintaining a stock of two different part numbers that are the same or acceptable alternative components. So those costs can really add up for us. So the challenge is introducing a tool set to allow us to easily identify these components for reuse. So the workflow in OnePart looks something like this, right? We need to be asking ourselves the question, do I need to design a new component? First thing that we do is we discover if it exists, and we'll use faceted searching. We'll talk about what the 6 W's are here in a moment. But we use a search box. It gives us a short list of possible designs, possible alternatives. We can then compare those selections together. We can look at a similarity score. We can look at some tolerance information between the components. We can find the parent-child relationship information in those files as well. And we can present the user with all of the information they need to be able to make that decision as to, is a new part necessary, or can I reuse an existing component? And the goal here is to be able to present you with that information in 60 seconds or less. Okay, so how do we do that? Let's take a look at what we call the faceted searching, the 6 W's: who, what, when, where, why, and how. There's a W there in how, so it does count. The system, as it indexes our data, is also indexing information about who created it, who modified it, what types of files are these, not only by file extension, but also by mechanical features, by material, by color, by component size. So what is it that we're designing? Where are these things located? In what data sources? What are the similarly shaped components? Things like that. When were they created? When were they modified? We can apply date filters to these as well. Drawings, related documents, additional metadata that may come from our various sources, descriptions, revisions, part numbers, you name it. And then, of course, our parent-child relationships, our related documents when a part number is called out in a specification sheet PDF or an Excel bill of material or things like that. Those will all return results as related documents as well. So the infrastructure, along the left, we've got our multiple data sources. Okay, this is really the key, is providing a single search environment for multiple data sources. So we may have an enterprise PDM vault. We may have several enterprise PDM vaults, independent vaults. We may have workgroup PDM. We may have file shares on a network. We may have a PLM system, be it Innovia, be it Windchill or TeamCenter, all of which have their own file access permissions, their own databases, things like that. And what we're doing is we're actually indexing the data in each of those systems into a single corpus or collection of index information that enables us to provide a single search interface across all those data sources. You do have to log in to the OnePart search engine, and that allows us to actually respect the security models in each of those independent systems. So you're being returned search results based on the files that you have permission to see, either your Windows permissions, your PDM permissions, your PLM permissions. So you're not being exposed to data that you shouldn't have access to. And all of this happens through your web browser of choice. So there's no client installation. There's no, there's no thin client. It is strictly a web browser that you use. So you can use it from mobile. You can use it from Chrome or IE or Safari or whatever your browser of choice is. There's no software to install. A couple of other notes about this system is it is based on an index. So in the background, on a schedule, it's going through and indexing the data in each of these sources so that you can be provided with instant search results when you run a query. It's not going out and searching each of these systems live. It's already done that, indexed it for us, prepared those results, and is able to return us instant results. Since we're just scanning that data and building up our own index, this would be what I call a non-intrusive system. So there's zero impact to your data sources. If you were to turn off EXALEAD one day, it would have zero impact on the integrity of the individual files and the individual data sets and data sources. So it's non-intrusive from that sense. Getting into a few more technical details here, Again, we're talking about pulling metadata information, property information from our files. We're talking about being able to index files for 3D similarity, character recognition, things like that. In terms of the data sources, we've got file systems, network folders, no problem there. We've got connectors for enterprise PDM and workgroup PDM. We've got connectors available for Smart Team, for Windchill, for Team Center, and there's other connectors available. These are the most popular ones. In terms of the CAD files that we recognize for indexing, again, beyond just the file name and file location indexing, we're talking about reference information, 3D shapes, custom property information. We've got the SOLIDWORKS family, draft site. We've got CATIA files, the offerings from Autodesk, from PTC, Siemens, and then neutral files as well, like STEP and IGES and STL, things like that. The Office Suite, PDFs, text files. We can index neutral files like XML or HTML, and then media as well, images, videos, other audio, things like that. As I wrap up the presentation and change gears into the product demonstration, really what we're looking to do here is increase our agility by enabling reuse from legacy data immediately, right? We can bypass the testing, the validation, the supply chain, because these are already files that we've done these exercises on, and we know where to buy them, who to buy them from. They've already passed our quality and inspections and things like that. So again, repurposing our existing designs and allowing us to focus more on innovation and new product development. Improving quality, decreasing risk. Again, we're leveraging proven components when we reuse our existing data. And then lowering costs to free up working capital. Again, allowing us to invest more in R&D, allowing us to spend more time innovating new products and less time re-engineering files and data that we already have. So we'll switch over to the browser here, and we'll get started by logging in to EXALEAD. So again, as I mentioned, it does require username and password to authenticate you and apply your user permissions in terms of the search results and what you're able to come back and see. One thing that I should mention here as well, this is an on-premise solution. So this would be hosted internal to your own network. You're putting in a server address here. It doesn't have to be a publicly available URL from the internet. It is an on-premise solution, so not public, not cloud-based. Your data is secure inside your own network. So we've got the search box here, and as I begin typing, you'll notice that it starts providing me with some suggestions. Okay, these suggestions are based on the data that is already indexed in my system. It also goes ahead and ignores my spelling mistakes. Okay, so it uses a keyboard approximation algorithm to anticipate what I'm trying to, type. So even if I make a spelling mistake, that's okay. It's still returning me those results that are close. A couple of things to note here, just from an interface perspective. Along the left-hand side, we have our search facets. Okay, the 6 W's: who, what, when, where, why, how. Okay, those are data that's automatically tagged for us. We've got the results screen here in the middle, and we can change our results style here. If I wanted to get a listing of the files to sort through, or thumbnails, we can view our data, we can visualize our data in a couple of different ways. We'll talk about some of the other view styles here in a moment. Along the right-hand side, you'll also notice that I've got some green boxes. The green boxes indicate the number of duplicate files in my environment. So if I come in here and click on that number, it will actually show me where these duplicate files exist. So we can see that I've got in my local files, I've got a couple of different user folders that I've indexed, and these folks all actually have the same identical file in each of their user folders. So again, identifying duplicate files for file cleanup made very easy here with EXALEAD OnePart. If I come in here, I'll run a different search now. I'll look for some mold tools here. You can see we're presented with some different information. I've got gray boxes here. The gray boxes indicate the number of child components. So if I actually come in and move into this search result here, we can see I've got parent-child relationships being identified for me. So it shows me what the parents are. It shows me what the children are. It also shows me how many instances of one of these child components are used in the assembly. So I've got 24 instances of this socket head cap screw in my mold base assembly here. I can return to the main screen here, and I'll quickly run a search of everything that I have indexed right now. And we can take a look at the facets over here on the left-hand side. So we've got creation dates. When were they created? When were they modified? If I want to filter down to a particular date range, all I need to do is click and drag over that time scale, and it applies that as a date filter. Okay? And I can continue applying date filters until I get down to the level that I'm interested in. We can see who was the file last saved by. What was this file? Were they SOLIDWORKS documents? Were they images? Were they from the Autodesk family of products? Are they parts, assemblies, components? What was the primary color for these components? So I can come in here and narrow down the search results, or refine my search results by applying these filters. Okay. If I look at some of my other filters available to me here, where is the file? So I've got different data sources. Some of my files are in an EPDM vault. Some of them are on my local network. Some of them are in a workgroup system. And again, just by clicking on the tag, we can apply that as a filter. You'll notice that the rest of the fields update accordingly as well. I can also use what's called the analytics view to filter down my search results. Similar to those facets that we had along the left-hand side of our screen, we get a more comprehensive view of our particular data set, users that have created our files, the family, the file extensions, the primary colors of our components here. What's the source of our data? And then some things that we don't get with other types of search technologies. So mechanical features. How many contain an extrude? How many contain chamfers or holes or shafts? How big are my components? What's the size range? What's the mass or the density? What material are they made of? So I can come in and start applying these filters in the analytics view. And if I return to one of my other search results views, again, those have been applied as as search result tags for me. So if we continue on here, I can also adjust my search syntax here. So you can see I've got 22 results when I search for a bearing flange, and a couple of those are PDFs. One of the ways to filter out my results is to use these tags over here and say, well, I'm not interested in the PDFs, maybe I'm just interested in parts, so I can narrow it down there. Or I'm interested in SOLIDWORKS files in general, so I can get my 17 results that way. I can also just change my search syntax here, and it understands some Boolean operations, so I can say bearing flange, not PDFs, and sure enough, I get my 17 results that are all my SOLIDWORKS components here. I can come in here and look at one of my files, and again, the 3D similarity is something that's unique to EXALEAD OnePart in that it's indexing the 3D shape of my files, and I can come in here and I can actually make some selections to compare, and I can add these all to my selection. And now this brings us to the compare window, where we've actually got a tolerance specified. So the items, the results that are being displayed to me are either gray, red, or black, depending on if the items match exactly, if they're inside of my tolerance or outside of my tolerance. So you can see here, in terms of volume, I've got a tolerance set of 15% right now. So my base model is just over 30 cubic inches. I've got my alternate here that's 26 cubic inches. That's within my 15% tolerance. I've got another one here that's 43 inches, which is outside of tolerance, so it's highlighted in red for me. And then I have another file here that's exactly the same volume. And in fact, if we look at the characteristics in general, it actually has a 100% 3D similarity score. So it's an exact match to the shape of my baseline result here. These other ones have similarities of 96%, 91%, 90%. So it tells you how similarly shaped these components are. Again, we're able to compare materials, mass, footprint size, features that get identified in the compare window here. So that's really what we wanted to show today for EXALEAD OnePart. So I thank you all for attending this afternoon, and look forward to discussing EXALEAD OnePart with you in the future. Thank you.